Hello folks, we come to the Misc.Ex exercise chapter 10. This is a part 7 video. Again, another three probably crucial problems that we are going to take up. All very important and lots of understanding. But question number 17 alone, I don't know, I feel that there is some data insufficiency. They give us 2 points with coordinates 1, 3 and -4, 1. They say that they are the endpoints of the hypotenuse of a right angle triangle. With the help of this, you have to find out the equation of the perpendicular sides of the triangle. They call it as legs. It's the legs of the triangle. If we use this and we have to find the legs of the triangle, I don't know, it doesn't seem to be so very easy to do it. So we thought we could actually plot it in the coordinate plane, and from there we could draw it. Probably that will be easier. So what we have done is we have taken the points, we have called these points as A and B, we plotted it in the coordinate plane, and from here let's find out the right triangle, and from there we can find out the equation of the right triangle. That's a geometrical approach of doing it. So we do it geometrically. What we do is we have plotted the point A and the point B. Let's write there, let points A comma B be as shown in the figure. As shown in the figure. We complete this figure to get the right triangle ABC. Okay, so we will draw perpendiculars, so we will be getting the right triangle. From here, this is the hypotenuse. It's clear to us, it's being told to us that this is the hypotenuse. Obviously, see, when you have a right triangle, you have this, you have the perpendiculars going from this point and perpendicular coming from this point, and that's how you get the right triangle. So we are going to drop perpendiculars from this point and this point. Wherever it meets, you will get the right triangle. So let's draw perpendicular from this point, drop a perpendicular from the point A. If we have a set square, we have to do it in a better way. This is how it is. This is how we draw the perpendicular from the point -4, 1. And let's draw perpendicular from this point 1, 3. Right. So it comes and it meets at the point C. That's how you have your right triangle. Right. So having dropped the perpendiculars, we complete the right triangle ACB, and from here it's very clear that the segment, or rather, the segment AC is parallel to the x-axis, and it is passing through the point 1. So anything that is parallel to the x-axis is of the form y equal to some A, and here it's 1. Similarly, this segment BC is parallel to the y-axis. The first one was parallel to the x-axis, so it's of the type y equal to something, and this is parallel to the y-axis, so it's of the type x equal to something, depending on where it is passing. It's passing from x equal to 1, so that way it will take the coordinate. So let's illustrate that. We complete the figure to get the right triangle. We observe that AC is parallel to the x-axis. Therefore, its equation is parallel to the x-axis is y equal to something. So y equal to what? Y equal to definitely 1. And BC is parallel to the y-axis, and its equation is x equal to something. It's passing through 1, so x equal to 1. So these both are therefore x equal to 1 comma y equal to 1 are the equation of the legs. Right. So that's what is the question all about. Somehow this could be, of course, geometric approach is always an easier approach, but this somehow, this is how it works. Then we have the 17th problem, very 18th problem, absolutely important from this year's point of view and from next year's point of view. We already learned foot of the perpendicular in the previous exercise. This is an extension image. Okay, so as we find the foot of the perpendicular, what we were doing is there was a line given, there would be a point. You have to find out if it's perpendicular, then what is this B? That's what we found out. Now we move one step ahead, image. If we have a point here, treat this as a mirror, it will form an image over here. See, we know how the mirror works. The image is formed behind the same distance. So at the same distance AB, it goes behind the mirror and there the image is formed. So you have to find the coordinate of AB. So as usual, how we found the foot of the perpendicular, we will find the foot of the perpendicular's coordinate. Then by using midpoint formula, we will be able to get the coordinate of the image. So till the foot of the perpendicular, whatever concepts we had done, that same concept we will be doing there. What we had done, we had taken out this point HK, it is belonging to the line L. So one equation we get from there, the other equation we get because of the slope, because it's perpendicular. And then you know one point there, like that, we frame one more equation, we solve it and we get the value of H and K. Once you get the value of H and K, we extend it by midpoint formula, you will get the C value. So let's quickly get across doing it. Let line L comma points ABC be as shown in the figure. Be as shown in the figure. Then let B with coordinate HK and C with coordinate AB be the foot of the perpendicular comma image of A under L. Right. So that much work we have indicated. Now as I told you before, HK is point B, here point B is lying. So first let's get that so that we gather that much point marks belongs to line L. So it will definitely satisfy the equation of line L. Satisfying means XY. So equal to 7, equation 1. That much we have counted. Now we look out for the slopes. Right, and slope of line L. Slope of line L minus A by B, we know. So it's like minus 1 by 3. Since AB is perpendicular to line L, so slope of AB will be minus 1 by 3. So that means it is 3. Directly also you can write B by A. That way also you can write. So it's 3. Slope of AB you know, and you know this point. Therefore equation of AB, because you know the point 38 is lying on it. Equation of AB is y minus 8 is 3 times x minus 3. Open it up. Y minus 8 is 3x minus 9. 3x minus y minus 3x minus y minus 8. So that's 1. But HK belongs to line AB, so it satisfies. So 3H minus K equal to 1 is equation 2. So solving 1 and 2. Solving 1 and 2. What will happen? You will have, can't we multiply this by 3? 3H 9K 21. 3H minus K 1. Subtracting. Gone. 10K 20. So K is 2. 20 by 10. Right. So let's have the H also. I don't know. I think I find this very simple, right? And 3H minus K equal to 1. So 3H minus 2 equal to 1 will give you 3H, 2 will go there 3, H is equal to 1. So therefore B12 is the foot of the perpendicular by midpoint formula. By midpoint formula, we know that C with coordinate AB will become no, C is not the midpoint, HK is the midpoint. We know that HK is 3 plus A by 2 and 8 plus B by 2. So that way 1 comma 2 will become 3 plus a by 2 and 8 plus b by 2. Let's solve it. Therefore, equating. 3 plus a by 2 is 1, 8 plus b by 2 is 2. So 3 plus a, 2 goes there, it's 2. So a becomes minus 1 when 3 goes there. Then 8 plus b equal to 4, and minus 8 goes there, plus 8 goes there, becomes minus 8, becomes minus 4. So you have the points minus 1, minus 4. Yeah, so the images. Therefore, the image of 3, 8 is minus 1, minus 4. Right. So that's about the image problem. We'll take the 19th problem. We divided some place, so we probably can take it here. 19th problem says that there are 3 lines given to us such that it's equally inclined to one of the lines. If that is the case, we are supposed to find the value of m. Equally inclined, we know tan. Yeah, tan theta, where angle between 2 lines is m1 minus m2 by 1 plus m1 m2. It's a huge data. That's all. That's what we're going to use. So let's have it introduced. Let lines L, M, N, comma point A, angles theta be as shown in the figure. As shown in the figure. Then we can take their slopes. Slope of line L, for our convenience we call it as M1. What will it come? 3 directly, very clear, by point slope form. Therefore, slope of line M, which is M2, is M again. Slope of line N, M3 is not so clear, because it is 2y equal to x plus 3, right? So 2y equal to x, y equal to something means you can get it. So let's divide by 2 on both sides. So x by 2, 3 by 2. Then you can get the slope as 1 by 2. Okay, since they are equally inclined. So since theta is the angle between L and M. Yeah, we know tan theta equal to m1 minus m2 by 1 plus m1 m2 with the famous modulus. So tan theta is m1 3, m2 m, 1 plus 3m. Solving we'll see later. And theta is the angle between m and n. So that way we'll have tan theta as m2 minus m3 by 1 plus m2 m3. We have the values m minus half by 1 plus m into half. We can do a little bit of solving rather than keeping it like this. Into 2 into 2 into 2 into 2. So it is like 2m minus 1 by 2 whole by 2 plus m by 2. They can cancel. So you have 2m minus 1 by 2 plus m. If you could call this as 1, you could call this as 2. Left hand sides are equal, so right hand side will be equal. From 1 and 2, because the left hand side is equal, the right hand side will be equal. So 3 minus m by 1 plus 3m in modulus form is going to be equal to 2m minus 1 by 2 plus m. Now to remove the modulus, one thing you keep it as normal, the other one you keep it as plus minus. So 2m minus 1, 2 plus m plus you keep, the other one you keep it as minus of, and then we can solve this. When we solve it, we'll get the values of m. Let's have them solved. 3 minus m times 2 plus m and 2m minus 1 times 1 plus 3m. 6 plus 3m minus 2m minus m squared, and here 2m plus 6m squared minus 1 minus 3m. Yeah, how will this work? 6 plus m minus m squared minus m plus 6m squared minus 1. Let's have everything on one side. So this can come here 7m squared minus 2m minus 1 minus 7. Right. Quadratic, and we can't break our head with the factors. 7 sevens are 49, hardly 7 into 7. Let's use the quadratic formula directly. So it is m equal to minus b, that's 2, plus or minus root of b squared, 4 minus 4ac, 4 into 7 into 7 plus by 2a. So 2 into 7. How much is it coming? 2 plus or minus 49 into 4. Or rather, I will take an easy way out. 4 common. 1 plus 49 by 2 into 7. 2 plus or minus. That can come out 2. Right? Root 50. Root 50 is 25 into 2 actually. So this 2 you can take common from everywhere. 1 plus or minus root 25. This is root 25 into root 2. And root 25 is 5. 5 root 2. 2 we have kind of 2 common. And that 2, this 2 is cancelling. That's it. This is one value, 2 values of m from this equation. Now we'll find out the value from that equation. So what will happen? 3 minus m times 2 plus m. This also can be written as minus 2m plus 1 times 1 plus 3m. Let's open up. 6 plus 3m minus 2m minus m squared, the other side. Minus 2m minus 6m squared plus 1 plus 3m. So it is 6 plus m minus m squared, m minus 6m squared plus 1, everything on one side, 6 and minus, so 5m squared, then m and m can cancel. Or rather, what? Or rather, let it come here. 6 minus 1, 5 equal to 0, 5 common. M squared plus 1 equal to 0, dump it on the other side by dividing. Then you have m squared plus 1 equal to 0 is reducible in real numbers. M squared, x squared plus 1, x squared plus anything will be always reducible in real numbers. Irreducible, you don't get a root. Doesn't have a root. If you want, you can substitute it in the quadratic, you'll get a complex number root, not a real number root. So m value does not exist. So only those 2 values of m are this. That's about the problem number 19. With the next chunk of problems in the next video. Thank you.